I'm Trever.
And I'm Raul.
And we are talking about some little hand sound pipes that we made. So initially, these are basically pipes just with nothing in them, and then you smack them, and what that does is it creates a velocity and high pressure that causes it to oscillate towards the end of the pipe, which is then replaced by a low pressure. And that causes the air to come back in and try to replace it to even out all the pressures. And then that causes a process to keep going until the sound either dampens or the sound's gone. Like, once the sound's gone, that's the process ending.
So basically this back and forth motion, it gets a little bit weaker every time. And so eventually the sound dies off because the low pressure, which is causing air to move back, gets slightly less low every time the process is repeated.
Yep.
All right. And we made these hand pipe instruments specifically so that children could understand how our ears interpret sound. Basically, if you ever played an instrument, a recorder, you have a certain length of tube and that corresponds to a specific length of sound. So can you talk about how that relationship works?
So whenever you have like a longer tube, that will either create a different note, and okay.
How about you, Raul?
What was the question?
So what exactly why does the length of the pipe matter with determining the note?
Because it establishes the wavelength.
So the wavelength of the sound means what exactly?
The wavelength of the sound correlates to the frequency, so they're inversely related, and frequency itself correlates to sound.
Right. So our ears interpret a frequency, right?
Right.
And that corresponds to the wavelength of the sound that generates it. And the wavelength of the sound with the frequency forms a relationship to determine the velocity of sound, right? In air, the speed of sound is about 343 meters per second, right? That speed of sound is what primarily impacts what length of pipe is needed to isolate a particular frequency of our sound, the note that we're going for, right? So I noticed that you have a smaller pipe than he does. What does that mean about the note yours generates?
It means that it would generate a lower note because of what you just said, so it would have a lower wavelength. Actually, it would have a higher wavelength.
So you got it a bit backwards, but that's fair. So your note is the lowest that we have, right?
Yep.
And that's because the longer the pipe, the longer the wavelength, as you stated, they're inversely related. So it has a higher frequency for lower wavelength. So longer wavelength is lower frequency, right? So your note is the longest we have. We also have this assortment of other pipes, which we can all use to create basic songs like Twinkle, Twinkle, Little Star. They're color-coded to make it easier for kids to work with. Why don't y'all demonstrate how y'all's pipes work together? How about y'all hit them at the same time?
3, 2, 1.
Right? So we have a chord, right?
Yeah.
Although it's not perfect tuning, we do have approximately the idea in mind, right? And we should be able to determine it, although it may be a bit painful to the refined ear. But this isn't going to be the deal. Anyway, guys, did y'all enjoy working on this particular project?
Yeah.
So if y'all had to take one thing away from this project, what exactly do you think you'd take away?
I think I would take away how the harmonics of the sound oscillating and the speed of sound and how that correlates with the length of the pipe, and that's what I would take away.
Right. So if we're in water, we need a different length of pipe in order to generate the same note because the speed of sound is different in water.
Exactly.
How about you, Raul? What do you think you'd take away?
I think
That
I'd
about
take away the same thing because I didn't know that we correlated with the medium that we're in.
Yeah, it is a bit of a cool thing, isn't it?
Yeah.
Alrighty, guys. Well, it was a pleasure working with you this semester. I look forward to seeing you all again.